12 hours ago, something happened in deep space that is forcing scientists to question everything they thought they understood about the universe. This is not speculation. This is not theory. This is raw, verified data coming from multiple independent observatories. And if even a fraction of it is accurate, then what we are witnessing right now may be one of the most important discoveries in human history. Let's begin with the moment everything changed. At exactly April 15, 2026, NASA's Deep Space Network recorded a trajectory update from an object known as 3I Atlas. At first glance, it was just another interstellar visitor, a rogue comet drifting through space like many before it. But this time, something didn't add up. The data revealed a maneuver with a probability so small, so precise, that scientists calculated it at just 0.00014% chance of occurring naturally. That number alone should stop you. Because what 3I Atlas just did is not something comets are capable of doing. Picture an object nearly 314 million kilometers away from Earth, moving at extreme speed through the darkness of space. Now imagine that object adjusting its path with perfect precision, not randomly, not chaotically, but with calculated intent, threading its way through the Orion belt, passing directly between three massive stars Alnitak, Alnilam, and Mintaka. That kind of accuracy doesn't just happen. In traditional astrophysics, comets are passive travelers. They don't steer, they don't choose paths. They are pushed and pulled by gravity, guided by thermodynamics, and influenced by random outgassing. Their motion is predictable, even when chaotic. But what we are seeing here breaks that model entirely, because 3I Atlas changed its trajectory by exactly 1.42 degrees. Not approximately, not roughly, exactly. And that single adjustment was confirmed by three separate systems. The European Space Agency's Gaia spacecraft recorded it independently. The ALMA Observatory in Chile cross-checked the telemetry. Different tools, different methods, same result. A precise shift happening at a precise moment aimed at a very specific location in space. Now, think about the physics behind that. This object is traveling at nearly 87 kilometers per second. At that speed, even the smallest change requires immense force and perfect timing. For a natural comet to make such a correction through random gas release, everything would need to align flawlessly: direction, pressure, timing, and duration. The probability of that happening by chance is calculated at 1 inch 14.7 billion. Let that sink in. Even more unsettling is what NASA's James Webb Space Telescope observed during this maneuver. At exactly 4:18 UTC, the object didn't just drift into position, it accelerated. Not under gravity, not due to external influence, but through what appears to be a non-gravitational force. The recorded acceleration was small, just 0.003 meters per second squared, but at the scale of an object estimated to weigh 33 billion tons, that is extraordinary. It's like trying to guide a mountain using nothing but a controlled burst of air, yet somehow achieving perfect accuracy. Scientists at the Jet Propulsion Laboratory immediately began reviewing their models. When institutions at that level react that quickly, it's not routine. It means something in the data doesn't fit any known explanation. But here's where it gets even more interesting. It's not just that 3I Atlas changed direction, it's how and where it did it. The new trajectory is not random. It is aligned. It is optimized. It is guiding the object directly through a gravitational corridor that minimizes resistance and preserves speed almost perfectly. That kind of path is something a supercomputer would calculate. And this is only the beginning. And if you think that trajectory alone is difficult to explain, What scientists uncovered next pushes this mystery even further beyond the limits of known physics. To understand why, we need to step back to when 3I Atlas was first discovered on August 14, 2025. At the time, it was categorized as a standard interstellar object, similar to previous visitors like Oumuamua and 2I Borisov. These objects pass through our solar system without showing any clear signs of artificial behavior. They were unusual, yes, but still explainable within the boundaries of astrophysics. 3I Atlas, however, quickly began to separate itself from anything we had ever seen before. The first real anomaly appeared on March 2, 2026. NASA's Hubble Space Telescope detected something that should not exist under any normal thermodynamic conditions. As the object moved closer to a heat source, instead of warming up like every known comet, its surface temperature dropped sharply. Not gradually, not slightly, but dramatically by 42 Kelvin in just 3 hours. This is the exact opposite of what physics predicts. Under normal conditions, comets approaching stars absorb radiation. Their icy surfaces begin to sublimate, releasing gas and dust, creating the glowing coma we observe. But 3I Atlas didn't behave that way. It cooled itself down while moving into a region where it should have been heating up. That alone would have been enough to trigger global scientific attention. But it didn't stop there. The European Space Agency's Gaia spacecraft independently verified the same thermal drop using its own instruments. Then, the Keck Observatory cross-checked the emission data and confirmed the result again. 3 separate observations, using different methods, all pointing to the same impossible conclusion. The object actively reduced its own temperature. Take a moment to visualize that. It's like placing an ice cube next to a fire and watching it become colder instead of melting. There is no known natural mechanism that allows this to happen on such a scale, especially in the vacuum of space. But just 16 days later, a second anomaly emerged. By March 18, 2026, scientists tracking the object noticed a dramatic change in its rotation. Normally, comets tumble unpredictably through space, their spin affected by uneven outgassing and gravitational interactions. Their motion is chaotic, constantly shifting. 3I Atlas did the opposite. It stabilized. The object's rotation locked into a precise cycle, exactly 4.14 hours per full rotation, with a margin of error so small it was measured at just 0.002 seconds. That level of consistency is not natural. It is mechanical in its precision. The probability of a naturally tumbling comet suddenly stabilizing itself into a perfectly timed rotation is estimated at around 0.0003%. Think about that for a second. Imagine a spinning top wobbling uncontrollably on a table. Then suddenly, without anyone touching it, the wobble disappears, and it spins perfectly straight, balanced with flawless symmetry. That's what we're observing here, but on a cosmic scale. Now combine this with what we already know. An object that can cool itself when it should be heating up. An object that can stabilize its own chaotic motion into precise rotation. And an object that has already demonstrated the ability to alter its trajectory with extraordinary accuracy. Each of these events on their own would be considered extremely rare. Together, they begin to form a pattern that suggests something far more complex than a simple interstellar comet. And then, on April 4th, 2026, something happened that pushed this mystery into completely uncharted territory. Because, for the first time in recorded astronomical history, this object didn't just behave differently. It started producing something from within, something that should not exist inside a frozen body of ice and rock. because what happened on April 4th, 2026 was the moment this object stopped being just an anomaly and started looking like something far more deliberate. At precisely 11:22 UTC, the Atacama Large Millimeter Array, better known as ALMA Observatory, detected a signal coming directly from the core of 3I Atlas. Not reflected light, not scattered radiation, but a structured, internally generated electromagnetic emission. This is where things become extremely difficult to explain. Comets do not generate their own electromagnetic signals. They reflect energy, they release gas, they scatter particles, but they do not produce organized emissions from their core, especially not highly structured ones. Yet that is exactly what was recorded. The emission lasted for exactly 72 seconds. Not approximately, not close to. Exactly 72 seconds, with no deviation. In 4 million years of recorded cometary observations across thousands of celestial objects, there has never been a single case of a comet producing an internally generated, polarized electromagnetic signal. Not one. Pause and think about the precision of that number. 72 seconds is not random. It is controlled, it is measured, it is intentional in a way that natural processes simply are not. Even chaotic astrophysical events like solar flares or pulsar emissions do not operate with that level of exact timing unless governed by very specific mechanisms. And that raises a critical question. What inside a frozen object, traveling through interstellar space, could possibly generate that kind of signal? Before scientists could even begin forming an answer, another development forced them to shift their focus again. Just days later, as 3I Atlas approached the outer boundary of the Orion constellation's gravitational influence, something remarkable happened internally. Observatories tracking the object detected a structural change not on the surface, but within its mass. The data suggested that the object's internal distribution shifted along its central axis. To put it simply, 33 billion tons of material moved, not randomly, not as a result of collision, but in a way that altered the object's center of gravity by exactly 14 meters. That level of internal adjustment is not something a passive celestial body can achieve. It requires energy, it requires coordination, it requires a mechanism operating from within. Think about it like this. If you were piloting a massive ship through a narrow passage, you would redistribute weight, adjust your ballast to maintain balance and control. From a distance, that's exactly what 3I Atlas appears to have done. And immediately after that internal shift, the 1-4-2-degree trajectory correction occurred. Perfect timing, perfect alignment. The path it chose was not arbitrary. It threaded directly between two of the Orion Belt's most powerful stars, minimizing gravitational resistance to nearly zero. The margin of drag reduction was calculated at just 0.001%, which is essentially optimal efficiency. That is not coincidence. That is calculation. By now, the pattern is becoming impossible to ignore. Every action taken by this object seems to serve a specific purpose. Cooling itself prevents structural breakdown. Stabilizing rotation creates a fixed axis. Internal mass redistribution allows precise maneuvering. And now we have a signal. A timed, controlled, internally generated emission. If each of these anomalies existed on its own, scientists might still argue for rare natural explanations. But stacked together, within such a short time frame, the probability collapses to almost zero. The combined likelihood of all these events occurring naturally has been calculated at 1-inch 4.7 trillion. That number is so extreme it effectively rules out coincidence. And yet, the most unsettling development was still ahead. Because on April 10, 2026, something appeared around 3I Atlas that should not exist under any known physical model. Something that changed the entire conversation. For the first time, scientists detected a magnetic field. Because the moment a magnetic field was detected around 3I Atlas, the entire framework of explanation began to collapse. This wasn't a minor fluctuation or a measurement error. At exactly April 10, 2026, at 1714 UTC, NASA's Deep Space Network picked up a clear and measurable disturbance in the space surrounding the object. At first, scientists assumed it might be interference or background noise, but within minutes, independent verification came in. The European Space Agency's Gaia spacecraft confirmed the same signature. Then, the Parkes Observatory cross-referenced the polarimetric data. 3 different systems, 3 separate confirmations, all pointing to the same conclusion. 3I Atlas had generated its own localized magnetosphere. The recorded strength was approximately 0.04 Gauss. Now that number might not sound significant at first, but in the context of a comet, it is extraordinary. Comets are composed primarily of ice, dust, and rock. They do not contain molten metallic cores. They do not have the internal dynamo required to generate magnetic fields. Simply put, they lack the physical structure necessary to produce such a phenomenon. And yet, there it was. A perfectly formed magnetic field surrounding the object with clear boundaries, behaving not like a random disturbance, but like a controlled shield. Take a moment to imagine what that means. You are observing a frozen object in deep space, and suddenly, around it, a structured magnetic layer forms almost like a protective barrier deflecting incoming radiation. It wasn't static either. The data showed that this field wasn't just present, it was evolving. At T-36 hours before entering the Orion corridor, the field activated. At T-24 hours, its intensity doubled. At T-12 hours, it synchronized perfectly with the object's stabilized rotation. That level of coordination is not something nature casually produces. It behaves like a system. And when you align this with everything we've already seen, the cooling, the rotation stabilization, the internal mass shift, and the precise trajectory correction, a clear pattern begins to emerge. Each event is not isolated. Each event is part of a sequence, building toward a specific outcome. Survival through a high radiation environment. Because the Orion belt is not just visually striking, it is an extremely active stellar region emitting intense radiation that would normally destabilize or even destroy a fragile icy body. Any standard comet passing through that region would experience rapid heating, structural stress, and eventual fragmentation. But 3I Atlas did something different. It prepared. It cooled its surface. It stabilized its spin. It adjusted its internal mass. And then, just before entering the most dangerous part of its path, it activated a magnetic shield. That is not coincidence. That is strategy. Let's put this into perspective using probabilities. The chance of a comet naturally cooling itself by 42 Kelvin is already extremely low. The probability of a nonmetallic body generating a magnetic field is effectively 0. When you combine those two events occurring in the same object at exactly the right time, the statistical model breaks down completely. It's like winning the lottery every single day for years while simultaneously predicting the outcome of each draw with perfect accuracy. It simply does not happen. From a physics standpoint, creating a magnetic field requires a mechanism, typically a rotating core of conductive material generating currents. 3I Atlas, based on everything we know, should not possess such a system. It should be inert, passive, and incapable of producing internal energy on that scale. And yet, the measurements were clear. The field had defined edges. It maintained stability. It responded dynamically to the object's motion. It behaved less like a natural occurrence and more like an engineered solution. And just when scientists were struggling to reconcile this with known physics, another discovery pushed the situation even further beyond explanation. Because on April 12, 2026, a new set of data arrived from the James Webb Space Telescope, and what it revealed inside the cloud surrounding 3I Atlas should not exist at all, because what the James Webb Space Telescope detected on April 12, 2026 pushed this mystery beyond anything science was prepared for. Using its advanced NIRCam instrument, the telescope analyzed the coma of 3I Atlas, the cloud of gas and particles surrounding the object. Under normal conditions, this region should contain simple compounds like water vapor, carbon dioxide, and traces of carbon monoxide. That's what every known comet produces. But this time, the data showed something entirely different. The readings revealed the presence of ionized metals. Specifically, titanium and vanadium, making up nearly 4.2% of the total coma composition. That is not just unusual, it is physically inconsistent with everything we understand about interstellar objects. These metals require extremely high temperatures to ionize, conditions that simply do not exist around a cooling, frozen body traveling through deep space. Think about the contradiction. An object that previously reduced its own temperature is now somehow maintaining ionized metallic particles in its surrounding cloud. That requires energy, sustained, controlled energy. 3 independent observations confirmed this. The measurements were cross-verified, rechecked, and validated. The conclusion remained the same. This object is not behaving like a natural comet. Every action appears purposeful. Cooling to preserve structure, stabilizing rotation for precision, generating a magnetic shield for protection, adjusting its mass for navigation, and now releasing ionized materials that should not exist in this environment. Individually, these are anomalies. Together, they form a system that appears to be operating with intent. And that raises one unavoidable question. If this object is actively functioning, then what is powering it? Because the answer to that question could change everything we know about our place in the universe. If you want to uncover what happens next and what this object might truly be, stay with us and make sure you don't miss the final part.